Okay, in this brief lecture, I want to talk about the difference between mental maps and cartographic maps and give some examples of cartographic maps and their use. So, first of all, I wanted to start with the historical definition of a map as opposed to a globe. So, if we go down to points 2 and 3 there, maps were thought of as a two-dimensional representation of the Earth's surface or a portion of it. And it's useful for you to keep that in mind because it's still, in many ways, a good working definition, especially when you look at how maps are differentiated from globes. And a globe is a three-dimensional representation of the Earth's surface or a portion of it. So back up to the top there, geographic maps are really abstractions of the world we live in. And as mapping has gotten more complicated and our ability to depict the world around us and represent that world around us has gotten more complicated, the definition has needed to broaden out in some ways. So we're able to then do an abstraction of the world and map out phenomenon within or above its surface. So even things like weather maps often don't really map the Earth's surface as such. They're mapping patterns in the atmosphere as well as maybe locations on the ground for reference purposes. It's important to keep in mind that what we're doing here is working in representation, and a representation is a model or a simplified version of reality. So we do need to be able to keep in mind that one of the major goals of mapping is to make decisions about what information a map conveys, and that information should then relate to the intended use of the map. Two categories of geographic maps are mental maps and cartographic maps. Mental maps, first of all, relate to the visualization of a place based on direct and indirect experience. This means that people tend to develop geocentric views of places. That is, that we can't help the fact that our knowledge is based in part on our experience, and the world around us would then be close at hand. Hopefully people are able to then begin to develop a sense of geographic literacy about the world around them and then transfer that to some kind of mental map. It's driven by perception of the environment and what's on the Earth's surface. At the most basic level, it is related to the location perspective of the individual. This is a good example of a geocentric view, which was a comic drawn in the 1970s to depict the Upper Peninsula view of Michigan as opposed to the view of Michigan that typically features the Lower Peninsula more than the Upper Peninsula. And so you can see there the features are expanded, the world looks kind of like an odd shape, but it's a geocentric view that relates to that person's mental map and mental understanding of what Michigan means in that case. Here's another view of a mental map, in this case, the world of the 1940s. This is from a World Regional Geography textbook, and it shows the importance of the individual. So, for example, where my mother killed chickens to cook shows up as a place on the map, and so does the church, where the father was a Presbyterian minister, and my dog Skippy, and all kinds of things. And then you have houses and driveways and woods and so on. And this just gives a sense of the way that we tend to develop a view of a place based on our own experience. Here's another one that relates to the way we navigate the world, and there's a lot of talk these days about navigation because of the impact of satellite navigation systems and GPS, and people often will complain about how people just use their GPS and that's how they get around, and they're not developing a sense of geographic literacy and all kinds of things like that. And there are lots of different perspectives about the use of satellite navigation and how it's impacting our views of the world. Geographers, cartographers, GIS experts tend to focus on this quite a lot. There's a whole area of research based on the way that human cognition is responding to geospatial technology over time. In this case, the kid in the car says, "I can only show you the way back to my house if you drive me back to school first." And this reflects the idea that we navigate the world in a very specific and often narrow way, even though at that point, they were just right down the street from the house when they had to go back to the school. So cartographic maps as opposed to mental maps. Cartographic maps have basic characteristics. There are 5 characteristics of cartographic maps. I'll mention them here on this slide, then we'll go through and see some examples of each one of these. First of all, maps are vertical or oblique views of the environment, and we need to be aware of which is which when we work with maps. Maps are created at a reduced scale with a relationship between map distance and ground distance. Maps are made on a map projection surface. Maps are generalized representations of the environment, and maps are symbolized representations of the environment. And in order to be a cartographic map, a map should have at least one of these 5 characteristics. So first of all, this is a map that shows a vertical view of the environment, in this case the area of the Middle East occupied by people who are identified as Kurdish ethnicity, and it shows an area of the world in a, it's kind of a simple map that's just intended, and this is a good example, by the way, of a thematic map. It's intended to show where a particular culture group lives in the world. Good use for a... Here's an example of an oblique view of a map. In this case, it's an avalanche zone, an area that has some ski runs, and you can see that an oblique view is a good choice to be able to visualize this 3-dimensional surface within a 2-dimensional environment. And so it allows you to get a look at the relationship between the different geographic features and have some sense of elevation and the spatial connection between these different geographic features. Type of map. Maps are created at a reduced scale, so we can't represent the world at a one-to-one relationship, so we do need to be aware of what the scale is that we're working on for a particular map. And so we see up in the upper left corner a smaller scale map, and this shows us all of the Pacific Northwest. And then moving over to the right, we're increasing in geographic scale as we zoom into the Pacific Northwest, and then the Seattle area, and then downtown Seattle itself, where now you can see ferry routes and streets and patterns where buildings are located and things like that. And so what you can see then is none of these maps is necessarily better than another. They just would all have different uses. So again, the use of the map is an important factor. And maps are made on a projection surface. So the way we draw a map is based on how we translate a 3-dimensional globe onto 2-dimensional space. The challenge here is that it's actually impossible at a global scale to translate a 3-dimensional surface onto 2 dimensions without having some kind of distortion. So much of the question of how we use map projections and which map projections we choose comes down to, again, the use of the map. What's the purpose of the map, and how does the projection relate then to which projection we choose and what it's depicting for the map. This is a major focus of geospatial technology, as you'll see as the semester progresses. The generalization of maps is very important, and here's a good example where state and U.S. highways have been generalized with a very thick red line. This makes that line out of proportion to the scale of the highway in terms of how it would appear on the Earth's surface. But the point of this map isn't to show the size of the route, it's to show its location so someone can use it to get across town. And so this inset map is from the 1950s from a Michigan State highway map, and it's a good example of one where we see generalization at work. Then symbolization, and here's a good example of a symbolized map. In this case, the map at the top is from a tourist map of the city of Berlin, and circled you can see the Brandenburg Gate, and so it shows the shape of it. So if you were walking up to the Brandenburg Gate, you could recognize the shape of it based on the symbol on the map. And the way that's symbolized, it's quite simple, and it doesn't actually look the way it does from Google Earth, which is the map at the bottom, where you can only see the vertical view of the Brandenburg Gate. You could zoom in and get an oblique view as well, but it's still not going to show up the same way that map symbol, which makes a recognizable place for the city of Berlin. Also, I circled the S and the U up to the northeast, which would be to the upper right of the Brandenburg Gate, and you can see that S and U, they're circled in purple. Now the point of that, it's not that there's a giant S and U on the map, obviously. Those are map symbols, and it's meant to direct someone to the S-Bahn or U-Bahn, which are the part of the public transportation system within Berlin. And so this is just a zoomed-in view of the same thing. And we see map symbols at work all the time. We take them for granted in maps. They're an important critical factor in terms of how maps are designed and how they're used. And that concludes the slides on cartographic maps.